Hi guys, today we're going to cover 2.1 equations. Okay, so we have only one learning outcome. Okay, so we're going to solve the equations involving sets, indices and logarithms. Okay, so if you refer the notes that I've given you, so for 2.1 equations, basically we will discuss these three types of equations: indices, sets and logs. Okay, so for the sets, there is a reminder here. We need to check answer. Okay, for logarithms, we need to check answer. Okay, after we get the answer, we need to check whether it satisfies the equation or not. Okay, why we don't have to check for indices? Okay, because we know indices equation is any equation in the type or any function in the type of this. Okay, so where a is the base and x is the index, or we can say the power. Okay, so if we see here, the power, it can be anything, element of real numbers. So whatever answers we get, so we don't have to check because it satisfies this. Okay, x can be any real numbers, but not for cert. Okay, for cert we have to check answer because we know for cert, if you have this cert symbol, any number inside the set, it has to be greater equal 0 because we cannot have set of negative number. Okay, what about log? Okay, for log also, if we do have log of, if you have log of something, for example, so we need to bear in mind that that number has to be greater than 0. So that's why we do have conditions for these two. Okay, we do have conditions for these two, and therefore we have to check answer every time. Okay, so now the first example that I'm going to discuss is equation of index equation. Okay, so let's try to solve this past year question. Okay, so you may find this past year question in tutorial book. Okay, so let's see. Okay, we are given two equations here. 81 to the power of y equals to 3 to the power of 2y minus 3. Okay, multiplied by x. And then we have 2 to the power of 18y plus 6x equals to 64 to the power of x times y. So find the values of x and y. Okay, so this is index equation. Okay, so we take out the information given. So we have 81 to the power of y equals to 3 to the power of 2y minus 3 times x. And because we know that 81 is 3 to the power of 4, so we rewrite 81 as 3 to the power of 4, and the right hand side we just copy back, minus 3 times x. Okay, so now how to simplify this? Okay, we are going to use one index law saying that if you have a to the power of m to the power of n, so we are going to multiply the power. So we have a to the power of m times n. So that is what we're going to apply. So we will have 3 to the power of 4y equals to 3 to the power of 2xy minus 3x. Okay, and then we have same base on both sides, 3 and 3. So we can compare the power. So by comparing, so we compare the power. So we have 4y equals to 2xy minus 3x. Okay, so this is one equation that we have because we have two unknowns, right, x and y. So that means we need to have second equation so that we can solve both x and y, or else we will not be able to solve because we have only one equation but two unknowns. So therefore we are going to use this second equation. Okay, second equation we are given as 2 to the power of 18y plus 6x equals to 64 to the power of xy. Okay, so we see the lowest base in this equation is 2, and we know that 64 is 2 to the power of 6. So we rewrite 64 as 2 to the power of 6. Okay, and then on the left hand side we just copy back and we apply the index law just now. So we have 2 to the power of 6xy. And again, because we have same base on both sides, so we can compare the power. So by comparing, So we have 18y plus 6x equals to 6xy. So this is the second equation. Okay, and because we have two equations and we have two unknowns to find, so we can solve this simultaneously. So if you notice, we have 6xy here. Okay, and this one we have 2xy. So we're going to multiply by 3 so that the 2xy will become 6xy. Okay, so we will have 12y. Okay, and we bring this negative 3x to the left hand side. We have plus. Okay, 3 times 3 will give you 9 equals to 6xy. Okay, we have 6xy here and 6xy here. So we equate these two. So we can get rid of 6xy. We have 12y plus 9x equals to 18y plus 6x. And we collect all x on the left. So we have 3x, okay, because 9x minus 6x. And then we collect all the y's on right hand side. So 18y minus 12 will give us 6y. And then we have x equals to 2y by dividing both sides by 2. Okay, so now we have this. So we are going to substitute. Okay, substituting x equals to 2y into the first equation. So we will have 4 times y equals to 2x y minus 3x. Okay, so we will have this all equation in terms of y. So we simplify first. And then we collect everything on one side. So we have 4y squared minus 10y equals to 0. So we factorize because this is quadratic equation, right? So we need to show either one of the three methods, factorization or completing the square or by using formulas. So in this case, factorization is possible, so we factorize. Okay, so we have y equals 0 and y equals to 5 over 2. Okay, we have two answers here for y and we accept both, because again, okay, y is the index, so we can accept anything which is real number. So now we rewrite, okay, since x equals to 2y, so when y is 0, x is equal to 2 times 0, which is 0. Okay, and then when y is 5 over 2, so x is going to be 2 times 5 over 2, which is 5. Okay, and we accept these two answers because again, for index, okay, index must be element of real numbers. Okay, just now we discussed how to solve index equation. So next we're going to discuss on how to solve surd equation. So in order to do this, so I get one example from your tutorial book, tutorial question number 2C. So we have surd equation here. So how to solve this surd equation? Okay, so we have two surd symbols on left hand side and one integer on right hand side. So in order to simplify this, okay, so we are going to let this x minus 2, set x minus 2 on one side, and we move this, okay, set x plus 3 to right hand side. Okay, x plus 3. Okay, then how to get rid of the set? So we are going to square both sides. So if you see on the left hand side, if you square the left hand side, so set is, okay, this one is basically to the power of 1 over 2. So to the power of, okay, 2. So 1 over 2 times 2. That means the surd symbol will be gone. So we have x minus 2 here. And then this one, okay, 1 plus surd, x plus 3. So 1 plus surd, x plus 3. Okay, we're going to expand this bracket. So we'll have 1 plus surd, x plus 3 plus surd, x plus 3. And surd x plus 3 times surd x plus 3 will give us x plus 3. That means the surd will be gone. So we simplify this one plus 3 will give okay, 4. Okay, then surd plus surd will give us 2, surd x plus 3. Okay, then we rewrite the left hand side, x minus 2. So remove everything. Okay, remove all terms without the surd to one side. So you can see x minus x. Okay, then we bring the 4 to the left hand side. So we will have negative 6 equals to 2 times surd x plus 3. Okay, again, okay, we still have this surd symbol, right? So how to get rid of this surd? We again square both sides. Okay, so we will have 36 equals to 4 times x plus 3. Okay, then we will have x plus 3 equals to 9. Okay, 36 divided by 4 is 9. So x is 9 minus 3 will give us 6. Okay, but then, do we have to accept or reject? Okay, because just now I explained that whenever we have surd equation, we have to check answer, right? Okay, why is this? Again, because surd, if you have any number inside the surd, okay, the number has to be greater equal 0. Okay, so, and we need to check whether it satisfies the equation or not. Alright, so now let's substitute. Okay, 6 into, so this one, okay, we call this left hand side, and this is right hand side. Okay, so if we substitute x equals 6 into left hand side, so we have surd 6 minus 2 minus with surd 6 plus 3. So we have square root of 4 minus square root of 9. So we have 2 minus 3, which is negative 1. But then the right hand side is 1. So since left hand side is not equal to right hand side, okay, so we can say that x minus 6 is rejected. So in order to find answer to this, we don't have any solution. The third type of equation that we are going to discuss today is log equation. In order to accomplish this outcome, so I'm going to get one example from past year question 2008-2009, question number 9. Okay, so how are we going to solve this equation? Okay, so we have this equation 3 log base x 3 plus log base 3 cube root of x equals to 10 over 3. Okay, how do we solve this? Okay, first thing first, okay, I'm going to copy down first the equation. So 3 log base x3 plus log base 3. Okay, cube root means x to the power of 1 over 3 equals to 10 over 3. Okay, so we see here, we have this base x and this one is base 3. So in order to solve log equation, so first thing first, we need to make sure that the base is the same for all terms. So in order to do this, we need to change base. So it's either change base of the first term or base of the second term, either one. So it depends, okay, on how we want to change the base. So, but as for me, I'm going to change the base of the first term. So we are going to have 3 log base 3 over log base 3 x equals to, plus 1 over 3. So we bring this to the front by applying log law. So log base 3x equals to 10 over 3. And we know that here log 3 base 3 is 1, right? So we have 3 over log x base 3 plus 1 over 3 log x base 3 equals to 10 over 3. Okay, so in order to simplify this, okay, to make this expression simpler, so we are going to let log base 3x equals to m. So what do we get? So we have 3 over m plus m over 3 equals to 10 over 3. So in order to get rid of the fraction, okay, so we're going to multiply both sides by 3m. Okay, so what do we get here? So we have this 9, okay, plus m over 3 times 3m will give us m squared equals to 10 over 3 times 3m. So we will get 10m. So we're going to get a quadratic equation of m. So we bring everything to one side. So we will get this. And again, for any quadratic equation, so you need to show the method of the solution. Okay, so we need to show either factorization, completing the square, or using formula. So in this case, because factorization is possible, so this factorization must be shown clearly. Okay, so we have m equals 9, m equals 1. But again, we need to have the value of x, not m, so we replace back this. Okay, so we have log x base 3 equals 9, so x is equal to 3 power 9. And here log x base 3 equals 1, so x equals to 3 power 1. So do we have to accept both answers? Okay, so we need to check first. Okay, so we substitute these two into the equation. Yeah? So if you substitute back, so okay, you will find that satisfies the equation. Okay, so if you after you check the answer and you find that these two satisfy the equation, then we may accept both answers.